Hello everyone. In this video, let's discuss problem C2 colors of educational code forces round 176. The problem says Monocarp has installed a new fence at his summer house. The fence consists of n planks of same size arranged in a row. Monocarp decided that he would paint his fence according to the following rules. Each plank of the fence will be painted in exactly one color. The number of different colors that the planks will be painted in it is exactly 2. The number of planks of the fence that are painted in the same color must form the continuous sequence, meaning that for all pairs of planks painted in the same color, there will be no planks painted in different color between them. Okay. Monocarp has m different paint. The paint of ith color is sufficient to paint no more than AI planks of the fence. Monocarp will not buy additional paints. Your task is to determine the number of different ways to paint the fence to satisfy all Monocarp describes. Two ways of paint are considered different if they exist a plane that is painted in different color. Okay. Basically, the question says is like you have some n planks, like n planks, right? And m different color. Yeah. Suppose these are your n planks, like one, two, three, up to n, and you have some paint, the form of array, like A1, A2, A3, up to AM. Now we can take two elements from this pen, like uh, and we can color in like color contiguously. Like we can color first like this, then we can color the less. Like, okay, and we have to color in exactly two colors. Now the thing is, the color that we can choose, like we can choose any color. Like if we choose A1 here, we can choose out of these any colors and see if that we can able to color all n planks or not. Okay. Suppose A1 value is 2 and minimum we have to color, like we can't have only one color. So two color option with like at least one has to be colored with that color. So here if and the possible values we can choose for A1, like first color is 1 or 2. Suppose we color with 1 here, then we will find those colors which are greater than equal to n minus 1 to paint the remaining n minus 1 blank. Suppose here A3 is n minus 1, value is n minus, then we can choose A3 and paint like with A3 color here. Suppose AN was also n minus 1, then we can use AN also, like some that will having some different color, like we can paint with AN also. Okay. Answer here for A1 it could be, suppose there are only two options, then 2 plus, when we choose 2, then what would be the answer if we choose two elements, like first two elements? We have to see what all are there which are greater than equal to n minus 2. So these two are already greater than, suppose some AX is also greater than equal to n, then answer, if there are only three elements, then answer would increment by 3. L- Like this, we will iterate through the array. Like first we will check for A1, then A2, like this. Our answer will be the max of all possible combination. Okay, that we can able to paint this with two colors using two different color from paint array. Mm. So the brute force approach would be like you choose one element, like you will go iterating from there and choose first element like A1. Our option for A1 would be like 1 till A of I minus 1, not A of I minus 1, A of I, sorry. And we will try to find in the arrays which are like, if you are choosing one, then element which are greater than equal to n minus 1, or if you choose AI, then n minus AI, and we will sum those all values. Okay, like this we will go. for element and arm. The complexity here would be like iterating the array would be n, then finding like in n also we have to go till ai, so we can have that also n and iterating through the array again for finding the rest remaining second color basically. So this will go to n cubes, so which won't pass here. This solution we can improve by like sorting the array. Like if you sort this array in increasing order, like we can binary search in this array to find the like first index which is greater than equal to like n minus ai. Basically, if we choose different values of like if ai here till 1 to ai, we can binary search in this array and find the first index which is greater than equal to ni. Answer would be like if there are if the index is m, then this index is n minus I, and if it is the answer would be m minus ai basically. Index of this I, sorry. Okay. So by doing so, our complexity might reduce, but it would be like n square log n. Still, this won't pass. So to solve this, like the better approach is to not to go element wise. We will go like value, individual value wise. Like if the first option suppose is one, then if we color only with one and rest with different color, how many options are there? Similarly, when L is 2, like coloring these two, then what all other option do we have for coloring other pens? Like this, we will iterate till the max element, and the sum would be the sum of all those possible values. Okay, now how to do that? Basically, suppose these are the blanks 1, 2, 3, 4 till n. And suppose we have some arrays, okay, which will be sorted in increasing order. A1, A2, A3 till an. Now for all like L value, suppose L is the first value we are checking. We will go from 1 till the an. Like we can have first pending as an. Basically not an minus 1 till an minus, because second color we have to choose at least one pens. Now for all, now we will like if L is 1, we will see what all elements we can choose. So suppose this is greater than 1, then this all array will be greater than 1 because it is in increasing order. Then when L is 1, the first color I can choose is an option I have like here. And the second color would be I need paint which has at least n minus 1, okay, capacity to color. Suppose some AX value was there. So that second option I will have is n minus x. Like till this we can choose. And this, and we have to subtract also some common point when like suppose if we choose AX, we can have AX combination also, right? Or AX plus 1 combination also. So in that case, we have to minus that scenario. That would be the max of like these. Like if you have two line segment like this and this, the common values here is this line, right? This, which would be nothing more like we have these two values, maximum of these two. So we have to subtract max of. Suppose this was some index id x1, So this value is nothing like this is m, sorry, m minus idx1 is the first color option, and second option is m minus idx2, like, and we have to subtract m minus max of idx1 and idx2. Like we have to see what all option we have for like for every L we have to see what all option we have for choosing the first color and what all option we have for choosing the second color, and we will minus the common, that like choosing the same color twice, that we will minus. So that would be the answer. So time complexity here would be like this will go till n, and this we are doing binary search here. So which should like two times we are doing binary search, so it will be 2 log n, basically n log n, which would pass uh, this problem. So if I show you the solution, like it will be much more clear. This okay. So I first input nm, then this you can ignore. I was doing some mistake earlier, like I was approaching the problem differently. For m element, I input array. Then I sort in increasing order, and I iterate L equals to 1 till m minus 1, like maximum element. Like if m minus 1 is equal to n, then we can't choose the second element, right? So subtracting n from L will give 0. So we can't do in that. Otherwise, I will find the index for n minus L, and I will find the index for L if there is at least one valid index. My answer would be the elements from starting like L values or n minus L values minus I will do the common value that I will output. This is um, this is like temp answer is this I from previous implementation. This is ignore. Answer would be the summation of all those values, and we will print out. How I am finding the index is like I want the first index which is greater than equal to value. Okay, so if my last element is less than value, then I don't have anything in my array which has a value greater than value. I will return minus one in that case, which which case I will ignore this, not adding to my answer. Otherwise, I have at least I have the last element greater than equal to VL. Then I will do like L minus one R, and this I think you might be knowing by research. While R minus L less than, I will find the mid. If it is greater than equal to L, I will move R towards the mid. Otherwise, I will move L towards the mid, and R would be the holding my the first index which is greater than equal to L, that I will return. That's it. I think it was good question. It was basically a binary search implementation. Yeah. So that's all for this video. I hope you liked my explanation. If you have any doubt in my explanation, you can ask in a comment section. Thank you.